Hi, everyone. Thanks for your time today. My name is Anne Gabriel, and I am with Elsevier, and my talk today is about smart publishers and smarter content. So I'm probably not going to present as technical a presentation as you have seen today, but I think the business use cases for AI in publishing are very important. I recognize a lot of faces around here. I've been with Elsevier since 2000, in projects that related to technology and scholarly communication. We were all around for the big print to electronic migration, and now I think we're at the next great wave of how artificial intelligence and machine learning are really going to accelerate scientific discovery. So there was a long period while we all got used to P2E. Now we're here at the next forefront, and here's how Elsevier is engaging with this. We started to engage with it by actually revisiting our mission, and I think it's important to take a step back to think about why we're actually deploying AI and machine learning. Our customers are facing huge challenges in science and health, and they're really trying to maximize what they can do with an increase in research spend of 3.4% every year. However, we're in an area where there is increasing stress on things like peer review systems and library budgets, and how do we maximize that? Researchers actually lack the tools they need to be effective, and studies have shown that 70 to 80% of research asks the wrong questions and cannot be reproduced. The success rate of drug development is dismal. 1 in 20 are actually successful, and there's a $2.5 billion media pharmaceutical spend per drug. Imagine if efficiencies created through AI and machine learning could actually cut those costs even a little bit. We would have significant gains. And another area that our researchers are challenged by, and our clinicians, are preventable medical errors. So after heart disease and cancer, the terrifying statistic is the third largest cause of death in the U.S. is medical error. So if we can use AI and machine learning to mitigate some of those effects, I think that would be a win. So that is the big picture that Elsevier look at when we're looking at deploying AI and machine learning in service of our various clients and customers. And we're in a unique position to make a contribution to those challenges. I just wanted to back up even further and talk a little bit about how Elsevier sits in context with RELX Group, which is our parent company. Many of you may not know that RELX actually stands for something. R stands for our Risk Solutions Division, which is the fastest growing arm of Elsevier, and that has data like insurance records and car insurance records and bankruptcy records and weapons possession records. Elsevier is the scientific arm of Elsevier, which publishes 16 to 17% of the world's scientific information. LexisNexis publishes about 60% of laws globally, and Exhibitions is our exhibitions division, which has about 500 events in 40 countries with more than 6 million participants each year. So you can imagine how artificial intelligence and machine learning could be deployed not only across Elsevier, but across those groups to develop services like social determinants of health, or small pilot projects, one of which I'll describe later today, plug for my research metrics session, in looking at science impact on policy and science in the legislation. So how is the work that we're actually doing being measured in these spheres? For this, you need big data to do it, and I think the inflection point of AI and machine learning is now, simply because we have so much big data. So I'm just going to take a breath and say, thank you for all your sessions, and I'm concerned that the one thing that is in my mind is the fact that I need to get a Father's Day gift. It's like all this talk of AI, and all I can think of is, oh my God, it's Father's Day, what am I doing? So, Elsevier's content and innovation, we're using new capabilities. I was asked to talk a little bit about, how we are doing this. And I think it's a little bit different from some of the presentations you've seen simply because we are so large. Elsevier employs 7,000 people, but 1,000 of those are technologists. And that's a real shift from when I started in the company in 2000, when you had all of the individual publishers and they had their disciplinary fiefdoms and they couldn't imagine joining things on one platform to get to anything. So really, it's a huge effort to find the talent, to train the talent, and recruit that talent. And it's something that wasn't mentioned here, but I think it's something that everybody is faced with in this room. You know, how do I get the right people to work on these problems? We do that by partnering with academic institutions early on. We have some corporate partnerships with data science institutes, and we go to their career fairs and we actively work to recruit that talent into our organization. And one of the things that we're, asking that talent to do is really to turn that content into knowledge. So, we define content as anything good, published materials from journals, patents, the web, and client data. And then we're increasingly working with the metadata around that content, like citations, references, et cetera, to produce answers. So we're really moving from read this to find out more about it, to actually do this, to actually understand our customer base well enough that we can feed them answers that they want. And the case study that I'll share with you addresses that. We're really working on an evolutionary path to using natural language processing and machine learning to enable smart content, moving from what were historically manual processes using flat text to applying structure to it, with human intervention, to actually having the machines do it themselves. And I realize that sounds a little bit like "and a miracle occurs," but with 1,000 technologists, you get me here. So I'm not sure how that happened, but I think it's important to understand that we are really trying to almost unsilo, not to give your company a plug, the research process. So historically, we've taken all of these component parts that researchers have painstakingly put together, and we just wrapped it up all in a nice sealed PDF, and you can't get to any of it and understand it. And I think AI is about unpacking a lot of that and making it very useful. So when you want to talk about unpacking the PDF, what does that look like? So so here's a typical entry in the journal, in a journal. This happens to be the Journal of South American Earth Sciences, and some of the component parts that we seek to deconstruct include text, tables, equations, graphs, figures, maps, seismic profiles, and stratigraphic columns. So once we separate that out, we're able to actually make comparative values of one against another, and in other articles and in other journals, and compare across graphs, compare across images, and create that thing that humans can't do, because no one human can read it all themselves. So I'll take just one example of the many ways in which Elsevier and Relics are working with AI, and this is a recent successful example of something called ScienceDirect topic pages. And the idea was that we had also silos of content within Elsevier. We had what we call our reference use cases, which are the big, old, major reference works that, I shouldn't say old, they're new and they're changing all the time, but they're these foundational, I think, texts coupled with faster moving journal articles. And we discovered that researchers need information about unfamiliar concepts that they encounter, and they lose time searching for that foundational information and finding stuff that is trusted and citable. So our goal was to create relevant content on something called topics pages and enrich it with links back to the content. And what we needed to do was automatically identify good definitions from the text, and that involved processing a large amount of data with the understanding that most sentences are not definitions, and then ranking them, and also making sure that we had the right taxonomies to more closely define ambiguous concepts. To do that, we needed automation. We also developed strong predictive models, and most importantly, we still have human feedback looking at these definitions. We're not at the point where machines can do it all, and I think that this is a common message that we've all stressed, that it's not completely automated and that quality control is still an issue. So let's look at how this works. I'm not going to do anything online, but we do have the topic pages. And here's an example of what this looks like in some existing content. This is called the Atlas of Oral Microbiology, and you can see that it's subdivided into traditional chapters. I apologize, the screenshot is a little small. And what we've done is to extract and make topic pages from key components of the content from that atlas. And here it includes a definition of something called cell membrane, with quick definitions to shortly and quickly orient the user to the subject, and it enables them to understand what's embedded therein. It also includes relevant excerpts from the book and from the journal. So these are like componentized into content snippets where users can find them. And it meets the user where they are. They're on a search engine and they might want to find a definition for something. Here they're doing a search for pyramidal tracks. And what comes up is a ScienceDirect topic page, which leads them to those snippets and that knowledge. So right in the search engine, there's a boost. Also, we're working and embedding these definitions into our journal articles so that if you're on ScienceDirect and you're looking at, you know, one of our million or more journal articles and you have a definition, that will also point you to this content. So it's these content silos that are automatically referencing each other based on definitions that we've developed through AI. We have 100,000 topic pages that have been generated from ScienceDirect content. I mentioned over 1 million articles are being linked, enriched with these links to topic pages, and we plan to further expand this to more domains. We've had more than 3 million page views. And this wouldn't be possible without AI and machine learning. It requires taxonomy building. We built over 15 taxonomies in different fields to identify the most important concepts. We run our taxonomies across all Elsevier book content to identify the candidates for extraction. And then we use natural language processing and algorithms to identify the right sections of content to include in those snippets. And then we actually use a heuristic technique for relevancy ranking. And then we have that human factor at the end for quality confirmation. So that's how tech is being used. And here are some of the strategic benefits. And I think this is important for everyone here to know that 55% of users return to view more topics pages. 92% of surveyed researchers agree that topic pages help them achieve their goals. And the average views and engagement on topic page content was 155% higher than other ScienceDirect content pieces. We've had 33 million visits to topic pages since the launch less than a year ago in July 2017, and visits grew from 270,000 per month to an average of 6 million per month in that span of that 10 months. We have a 60% user return rate, and in April, ScienceDirect topics contributed to 8% of ScienceDirect visits. So that's a nice return on ROI. And we're not actually charging for this, but what it does allow us to do is to stress that value add for the customers of the content on our ScienceDirect platform and our books customers. So it's a very powerful way that this has worked out. ScienceDirect Topic Pages was a Codie Award finalist for 2018 in the category of Best Artificial Intelligence Machine Learning Solution. The judges' feedback said, "I love how Elsevier has tapped into existing resources to put this capability that adds value to existing users, but also serves as a lead generation and content analytics engine." So that indicates to us, I think, that we're on the right track with some of this stuff. Stepping back from that case study, the big picture is what we call compositional content and delivering focused content in digital environments, and that is breaking that up into those pieces that I discussed before. There are other applications that we're working on. For example, in health and precision medicine, we're developing image classifiers, looking across the images in the journal content that I mentioned previously. And also by publishing data sets and actively linking to them where they are stored on our Mendeley data platform. So the ultimate goal, and this is, I want to stress this is interoperable and includes not just Elsevier, but other entities, other publishers, academic institutions, is using these building blocks to create what we call knowledge graphs for research, looking at information that's coming from the publishing cluster, like journals and articles and conferences, but also ultimately incorporating data from the funding cluster, which would include patent and grants opportunities, and then organizational clusters where we also have data sets looking at institutional performance that can complement this. So AI is definitely part of our publishing. You said 2 years, 5 years, 10 years, it's now, and we're here. Thank you very much.